Hi, I'm Alex, and I'm here today together with Praveen to talk about containers and how they're going to change the way we ship software. So before I begin, a quick show of hands. How many people have heard of containers? That's pretty much everyone. Keep your hands up if you have used Docker, played with Docker. Kubernetes? Helm? That's basically not a lot. It's just the founding people. Anyway, OK. So basically what we're going to cover today is we're going to start with an introduction on concepts, just some basic concepts. Then we're going to go into examples from the wild of containers, of how companies leverage containers to deliver value or add value to their software. And then I'm going to hand over to Praveen, who's going to talk about how Redgate could leverage containers and containerization. And then we're going to look at what's next for Redgate in this sort of space. Right, so let's go back to the basics. Let's say I just want to run an application on my machine, right? I can just run a web application, and then it might have some dependencies. So it might depend on, I don't know, Python or whatever, Ruby, whatever. So those things have to be installed on the machine in order for the application to work. And let's say that application is exposing its contents on port 8000. So what if I didn't want to have to install those prerequisites on my machine? Well, I can use some sort of like virtualization, containerization, and then put everything inside. And then I'll be able to run that without having to install any of the dependencies on my machine or even the web application on my machine. But the problem with that is once I containerize, I've isolated all of that inside of that box of software, if you will. And I need to find a way to be able to access it from outside, so from my host machine. And then I need to do some mapping of that. So I need to map the port from my host machine into the guest machine so that I can use that web application. And that's actually not limited to web applications, if you think about it. I could just have some CLI running inside of a container or in a virtual machine. And then I could pipe the input into that, the CLI running inside of the container, and then get the output out of that into my host machine again. Right, but so that all of I've described can be achieved with virtual machines. So what's the difference between Docker? What does Docker bring to the table? So before I talk about that, I just wanted to get right on the terminology, because we keep talking about containers, but most of the times you hear the word images as well, and then what's the difference between those two things? So the idea is I like to think of these things as like source code and then DLL, and then your application running, or executables and then your application running. So think of a Docker file as kind of a recipe, your source code. And then when you build that, you get your image, which is like your DLL or your binaries, your executable. And then when you run that image, you get a container, which is an instance of that image running, if you will. So sometimes you hear people talking about containers when they really mean images. And I might say that during the talk, so forgive me for any missed terminologies. There's a few things that are cool about Docker. So the way that it builds the image, it really reuses layers, and then it does it in a very efficient way. But all that means for us is that it lends itself very well to sharing those images. So it's easy to push because it doesn't take a lot of space. It's easy to have it on your machine and easy to pull to a different machine. So that's the only thing that's important to know. If you want to know more details, there's plenty of documentation and information about that around. And one thing you can do with, because they are so efficient in the way they are stored, you can imagine them as being similar to what we do with Git. Like in Git, you have your repository locally, and then you can share that, pushing it to a remote, like GitHub. And then you can pull that source code in another machine, and then use that as well. So for Docker, what it means is that once you've built the image, you can then push that image to what they call a registry, which is equivalent to a remote in Git. And then from another machine, you could then pull that image. And then, in fact, you don't have to know that you're pulling it. When you do a Docker run, you will look for an image with that name in the registry and start running it straight away. So the good thing about that is that it's very easy to create Docker containers, and it's Docker images, and it's very easy to run Docker containers based on those images you create. It's going to make more sense in a minute. But now let's look at containers in the wild. So we're going to look at a few examples. So CLI, services, and databases, which Santiago has touched a bit before. Then we're going to look at a sort of different paradigm for using containers to add value to your software. And then finally, we're going to talk a little bit about orchestration. So I was talking about pushing images to a repository or to a registry. And then the most well-known one, the public one, is the Docker Hub, which kind of comes probably after GitHub. You know, it's the same thing that GitHub is, but for Docker. So the idea is that you can have an account there, and then you can publish an image, and then people can go and download those images and use them in the same way you can download, you know, source code and use it on your machine from Git. And then what this adds, in the same way that GitHub was like super important for the growth of Git, Docker Hub is important because it allows people to create and share images that can be used by other people. So if you look at this example, for instance, this is created by a company called Mesosphere, and it's a containerized version of the AWS CLI. So whoever tried to install AWS CLI on your machine, it's kind of painful. You have to install Python first, and then you need to have pip, and then you have to install it. Sometimes it doesn't work, the right version, then you can install it. It's a pain. So what this company has done, so notice that this wasn't Amazon. It was just someone that decided to containerize that. So they went on and containerized that CLI. So now you could use that without having to install it. So let's have a look at how this would work. So I would do a Docker run, and then I would do this RM. I'll explain in a minute. And then I will say the name of the image, Mesosphere AWS CLI. And then after that, I'm just passing command line parameters that will be then passed to the containerized AWS CLI that's running inside of the container. And then if I run that, I'm, in this case, not very interesting. I'm just asking for the version of the CLI. It will actually give me back the output of the CLI that's running inside of the container. And it was like, wow, that doesn't sound great, but it's actually super powerful because it means that I don't have to have Python installed on my machine, and I don't have to have AWS CLI. I don't have to worry about how it's packaged. I just want to consume that as a CLI without having to install it. So this is pretty powerful for CI purposes, or even for running on your machine if you don't want to install it. So let's just have a quick look at what those parameters mean. So RM means that it creates an ephemeral container. So what it means is that straight after you finish running it, you throw it away. So every time I call Docker run with that whole command, it spins up a container, it runs that command by passing the arguments to the AWS CLI, and it kills the container. It's stateless. So the cool thing is that it's very isolated and it's very repeatable. I don't have to worry about keeping state around, and that's actually a good thing. But you might be thinking, well, that's a very simple usage of it. What if I need to get some things that require my credentials, for instance? Then you can just pass some environment variables that define your AWS secret and access key, and then you can get issue a different command. For in this case, I'm getting the images in my ECR, Amazon ECR, which is the container registry. And then I could do that by just specifying some environment variables, which will be mapped to the container. And then I will be able to just access my account from there. Right. So far I've shown an image that was created by a random company, a third-party company. But actually, companies are starting to create their own images and publishing and maintaining those images themselves. So Santiago has shown some examples for Flyway. And then in this example, I'm going to use two images, so Postgres and Flyway, to test my migration script, let's say. So I'm using Flyway, which is kind of similar to SQL change automation, but in the Java world, I suppose. And then in this script, let's say I want to test my migrations onto an empty database. So what I do is first I create a container, which is my database container. And then I expose a port, so in this case, 5432. And then I run my Flyway container, which is the CLI, Flyway CLI containerized. And then I specify which database I want to deploy my changes to, or migrate, if that's the terminology that Flyway uses. And I only specify the username and password. And then when I run that, before I do that, when I run that, one interesting thing here is that in order for me to be able to access the database container from the CLI container, I need to use this host.docker.internal. So let's have a look at that. The thing is, because I'm running 2 containers alongside each other, they don't really talk to each other. They don't know about each other. That's the whole point. They are isolated. They don't know, they can't access each other. So in order to do that, there's a trick which you can use, which is to refer to the host machine by using this host.docker.internal name, which resolves to the host machine. And by exposing the port on the database container, I get to access that database from the CLI container. Actually, there's a better way to do it, which is by creating a network and then making sure both containers join that network, and then referring to and assigning the containers names so that you can refer to them by their name. So the change to the script will be that you need to create a network first, you need to give a name to the database container, make sure that they are both on the same network, so put network on both of them. And now instead of using host.docker.internal, you can use MyDB to refer to the database. So the only reason why I'm bringing this up is that when you use things in a containerized world, you have to consider the fact that they are not running on your machine anymore, and then they have some implications to how you're able to communicate between containers. Right. So I've shown one example, Flyway and Postgres, but there are actually images for pretty much anything you can imagine. And then most of them are managed by the companies that provide that kind of software. So, Santiago mentioned the Microsoft SQL Server one. You have MySQL, Postgres. And you even have some services around like Jenkins, GitLab, Discourse, WordPress, those kind of things. So it's very interesting how a lot of companies are already on that, I was going to say ship, like join like the train of containers or whatever. But that didn't work at all. Anyway, so before I go to orchestrations, I just wanted to mention a very, to me, it was sort of like a different way of leveraging containers that was very interesting. So Azure Pipelines is a CI/CD sort of thing. Think Tercete and Octopus all in one kind of thing. And the way they work is that you have your hosted, so it's a cloud, a software as a service kind of thing. And then you have some agents that run your builds in the same way that Tercete does. And then you can opt for hosted agents, which will run on the cloud, and you don't have to manage the infrastructure or anything. But the problem with that is that if you have a database on-prem, you can't quite access that. You might not be able to access that unless you expose it from the hosted agents. So one thing they did was very cool, is that they've released the Docker image for their hosted agent, which means that you can now run the exact same agent that it's run in the cloud on your local infrastructure without having to worry about setting up your agents at all. And then with that, you get all the benefits of running on-prem containerized agent, which is to access your on-prem resources like a database. So this is a pretty cool way of leveraging, of running in the world of cloud and on-prem and making sure you can balance those two things. And I thought it was a very clever way of using containers. So finally, I was going to explain what Kubernetes were, but luckily Robin asked the question and Santiago did the job for me. So I'm going to skip this bit. But what Santiago didn't talk about was that when you have Kubernetes, is basically managing all your containers and how long they live for and how many containers you need, if you scale down, scale up, all those kind of things. But then if you've used Kubernetes, it's kind of annoying. You have to type a lot of commands and do a lot of like kubectl things. So they came up with a way which is kind of easier to manage Kubernetes. So if you think about like Docker, and then you manage Docker with Kubernetes, and then now you need Helm to manage Kubernetes. It's almost like it's too complicated, but let's not talk about it. So the idea of Helm is that it sells itself as a package manager for Kubernetes. And then in my mind, I think of it as being the equivalent of, so Docker is to Helm what a DLL is to a NIGA package. So in that sense, you can just ship a Docker image, and that might be useful for someone in the same way they could just get a DLL and send someone a zip, or just email someone a DLL, and they could add them to their whatever solution and use that DLL. But a more maintainable, more manageable way to go about it is having a NuGet package, which you can handle all the upgrades, and you can actually bundle a lot of DLLs together and configure, have like an installed PSI that does some job to your project, these kind of things. So in the same way, Helm is a way of packaging your Kubernetes resources, which will manage your Docker images eventually. And then what that gives you is basically a unit which you can deploy to your Kubernetes cluster, and that basically behaves as a packaged application with everything it needs. So, for instance, it has a few examples. So it has a hub as well in the same way that Docker does. But you can think of it as a more complete story of a packaged infrastructure. So let's say you have GitLab, and then GitLab needs a database, and it needs a licensing server, whatever. And then the chart, which is the name for the Helm package, the Helm chart that it will be installed to your infrastructure, to your cluster, will contain every resource, every Kubernetes resource it needs to work. So you don't have to spin up a container here, make sure the port is exposed, spin up another one here, make sure it will scale up and down when needed. That whole thing is managed by the chart and is sort of like packaged in a way that you can just reuse those bits and even depend on other charts so that your deployment happens without you having to know the inner workings of the charts. Right, that was my part. So now I'm going to hand over to Praveen, who's going to talk about how Redgate can leverage containers.
Thank you, Alex. Can you hear me okay? Right. I'm going to talk about how we, Redgate, and our users could benefit by containerizing our tools. I'm going to talk about how could a containerized SQL compare CLI would look like, how can we use multi-stage build, Docker build for SQL change automation, and finally touch base on Redgate platform deployment models assessment by ThoughtWorks. So if the user wants to use a SQL compare today, they have to have .NET Framework 4.6.1 installed on their machine, and it can run only on Windows machine. So let's imagine if we can, this is an example of synchronizing to database using SQL compare CLI. What would a SQL compare CLI would look like if we were to containerize it? And this is how it looks like. So let's imagine we have ported our SQL compare code to .NET Core 2.2 and we have released an image with tag 13.6.0 into some Docker repository. And when the user wants to use it, the user are interested in only consuming the SQL compare CLI. They are not interested in its dependencies like .NET Framework or anything else that it prerequisites. So when the user types in Docker run SQL compare with the version number, it automatically downloads and the entire image onto the machine, and it's ready to run. Maybe it might take a little longer the very first time, and the subsequent time the image has been cached and it'll run instantaneously. Let's say in future we upgrade our .NET Core 2.2 to .NET Core 3.0, and we release a new version 14.0.0. And again, the user is interested only in consuming the SQL compare, not its prerequisites. So user would say, I would like to run the latest version like SQL compare 14.0.0 and its commands, and then it works magically. Here's an example of Docker SQL compare CLI if we have shipped SQL compare CLI as a Dockerized container. And as you can see, I have used Redgate serial number for environments. You can use a few other things like user credentials, secrets, and all these things through environment variables as well. And Redgate SQL compare is an image name. We give a specific version I would like to use, and followed by the command line arguments. These are just imaginary. It doesn't exist at the moment. Before I move on to the next example, I would like to talk a bit more about multi-stage Docker build. So if I want to build and run ASP.NET Core web application, I can just use SDK to build and run as well. So this example of Docker file uses SDK 2.2. It's a heavy lifted. And as you can see, the SDK source files and .NET Restore, when it pulls the NuGet package and everything, is all build dependencies. We don't want to ship those to the users. And the resulting image out of this would have everything inside it. So what would multi-stage build would look like for ASP.NET Core? We could separate them in two steps. One is a build step, another one is a runtime step. So during build step, the application would require SDK to build, restore packages, and all these things. And that will produce an artifacts that could be consumed by the subsequent steps. And it just uses only the artifacts and the runtime base image, which is ASP.NET 2.2. So in this instance, what will happen is the destined image would be much smaller because it doesn't have the full SDK, and it just only the runtime libraries it's interested in running it. So this is how it would look like. So you have two stage build process in your Docker file, and every single build step is called layers in Docker. And once the first build step is complete, it copies the contents onto the next build step, and it destroys the first build step. So you don't have that on your final containerized image. And when you run it, the container would be based on only the minimalistic build package. And there are few other very minimal Docker base images, like distro-less base images provided by Google, and that's available for .NET Core as well. And here's how you could just use Docker build. It doesn't matter what you have in the Docker file, multi-stage build or single-stage build, whatever it is. You just build and you run it, and it will just run your ASP.NET application. And this is how it will look like. So you have the host. Host could be anything. It doesn't necessarily have to be Windows, as long as it has got the Docker engine running on it. And you have the containerized application with ASP.NET dependencies in core dependencies in there, and it has mapped the port of 80 to the host 5000. So how would a multi-stage build can be used for SQL change automation? Again, this is imaginary. This is not at the moment. So let's say we have two base images for SQL change automation. One is like SDK to build the project and create artifacts. Another one is a runtime that can create a database from the artifacts on its own. So first stage would build the artifacts using the SQL change automation SDK, and the next one will use the MS SQL base image, just the runtime one, to create a database at that point in time. And let's imagine in future we support more databases like Oracle, Postgres, or MySQL. We would just have a very base image for those specific types of database, and the users would consume that image to create that specific databases. And finally, I would like to touch base on the recommendations from ThoughtWorks on Redgate platform assessment. They have proposed 3 deployment models. One is OS native, another one is Redgate provided cluster, and customer cluster. I'm going to talk about these two because those two requires our tools to be as a containerized tools. And in Redgate provided cluster, all the products, capabilities, and sidecars would be Docker, containerized images. And again, on the customer cluster model as well. There is one advantage of doing all these things is also like you could have one image that is built on a different language. For example, sidecar could be built on Golang if that seems to be more suitable for that particular purpose, if it has more advantage. Because everything talks to each other, and the dependency is well maintained within the container itself. So it's not exposed outside what it uses. It's just its capabilities that's been exposed outside. We all have the question, what if users don't have Docker installed on their machine? That's something that we come up very often. Docker is a new Git, and Alex is passionate about it. He's going to talk about that.
So I don't think Praveen agreed with this, so I'm doing this bit. So If you think about Git like 5, 10 years ago, you would never imagine that it would be used as a basis for a lot of package managers or things like that. For instance, if you think about NPM today, you can just get a package straight from a GitHub repository in the same way you can do it for the Go package manager. And then today, a lot of tools leverage Git, like Heroku. Heroku's deployment is done with Git, and then other things have Git inside that you probably don't even know. So what I think is, Docker is very likely to become the same sort of building block that Git has become to developer tools in the next few years. So the fact that people don't have Docker installed, it will be irrelevant because it will either be built in with whatever you ship, or it will be already a given that is installed on the server, or on the client's machine, or whatever. So, and I guess, what can we do to prepare for the future, you might ask? You know, you're talking about containers and all of that, but how do we get started? So I'll tell you how. You can just join the Docker Kata series upcoming. We're going to release that in the next few weeks. So we're going to run an equivalent to the web katas before Docker, and then probably going to dive into Kubernetes and Helm, that kind of thing as well. So we're going to announce that soon. And in the meantime, if you want, just go and play with Docker yourself. There are some online resources, so you don't even have to install Docker on your machine for those first two. And also the Docker documentation. It's quite a good resource to try. And then with that, thanks very much for listening.